Hello everyone, this is Dr. Zach. So the purpose of today's lesson is to give you an opportunity to practice your optimization problems and to review for that midterm exam. So take the time, complete the Unit 6 Lesson 3 notes to the best of your ability. Afterwards, go through and check your answers that will be provided on the video. So turn the video off, complete as many problems as you can, and then come back and check through some of the answers. So the first question that you worked on was a maximization problem. Ideally, you wrote that you're going to maximize your area or wrote your area formula. You have a nice little picture drawn. Now, how you label the picture could make the problem a little bit easier or a little bit more challenging. Really up to you. I like to call these x values along the base, x and x, so that my nice little equation becomes 2x plus 2y is equal to the length. Using Pythagorean's theorem, we then have h squared plus x squared is equal to your y squared. Solving for your h value by eliminating the y gives us the height is the square root of L squared over 4 minus XL. Next, we're going to find the derivative. The derivative is a lovely little product rule, and once again, you simplified in order to find those critical numbers. When you find your critical numbers, make certain that you're thinking about setting a derivative equal to 0 and trying to determine where the derivative does not exist. So both become very important. You have to decide if you want to use the second derivative test or the first derivative test. And of course, as you were looking at your problem, you decided the first derivative test would probably be best. Find your domain. The domain came from looking at your area problem. You knew that your x value had to be between 0 and L over 4 when you set the argument underneath the square root equal to 0. Next, you want to figure out the area at all of your endpoints, 0 and L over 4, as well as L over 6. Do your substitution, you come up with your L squared over 12 root 2, which you know is greater than 0. So you've found a maximum value. Make a statement. From the first derivative test, the maximum area is, and the dimensions are, now when you go back and look at your dimensions, there, remember, I used x and x. You're going to come up with L over 3. Resubstitute, and you're going to find L over 3 for the y value as well. So they're L over 3 on each side. Pretty cool problem. Now, many pieces of this problem might look different than what you did, but your answer should come out to be the same. All right, I wanted to remind you about solving related rates problems. Follow the guidelines that you've been practicing. And I also wanted to remind you about solving inverse derivatives. So the next question that you worked on. The entrance to a mine is enlarged, so it's kind of a rectangular shape. I've placed length as x, width as y, height as z. The reason I made those declarations is so that I could keep in mind which values are changing and how quickly. The question we're looking for is our dv dt at x equals 6, 2, y equals 9, z equals 9, y equals 2. Now the volume is 3 dimensions, x, y, and z. So when you used your product rule, you had to use the first times that derivative of the second. Now how you chose to find the derivative is your choice, but using the product rule was essential for this problem. Make certain when you answer the question, you're using the correct dimensions. So as a reminder, to find the derivative of inverse functions, begin by thinking about x and f of x. You know that f of x was given to you. Use your table of values and figure out the x value. You want to find the derivative of f prime at that new x value. In this problem, it's -3. Find 1 over the derivative of -1, and you get -1/3. So the derivative of the inverse at x equals 1, remember that is the x value of the inverse function, is going to be -1/3. On your second page, you had some mixed review. Once again, I wanted to talk about the inverse derivatives. Double check your work on that. Then we had another related rates problem. This one connected circumference to area. So after making that connection, determining how fast the area was changing should not have been too challenging. For question number 3, it's a composition of functions. Make certain you follow your notation correctly. You are looking for the derivative of f. Find it first. The derivative of f is 2x. Then substitute in your g of x. After you substitute your g of x, you should be able to find f prime of g of 2. Looking at your graph, do not be fooled. This is a limit problem. The function is continuous, and the limit does exist at 2. The derivative does not exist at 2, but the limit does exist. Limits will be on the midterm. All right, question 5. You were given dv dt is 600. You were asked to write the equation for dv dt. Then, given specific information, you are to find your dh dt. Make certain that once you answer a specific question that you have the units. Question C might have been a little bit more challenging. It mixes everything together. You were to find a maximum volume. Well, to find a maximum volume, you want to take the volume equation and set it equal to 0, but you don't know the volume equation. You do know how fast the volume is changing. So that is the derivative of the volume, set it equal to 0. Once you set your derivative equal to 0, you're also told in the directions that dv dt was a constant 600. So 600 equals square root of t. Solve, and you come up with t equals 36 minutes. Now the next part was actually the most challenging part. Justify your answer that this is a maximum. So when you justify your answer, think of your derivative equation as the change in volume. So if you were to find the second derivative of that, so I called this c of t, c prime of t would equal 0, remember dv dt was constant, minus m prime of t. But the derivative of m prime of t is always less than 0 for all t, which if it's less than 0, that made your function concave down at the critical point. So we know that t equals 36 is where the maximum occurs because negative m prime of t is less than 0 for all t through the second derivative test. So make certain when you justify your answer, you're either using the first derivative test or the second derivative test. You can also use your extreme value theorem if you have endpoints. So your lesson follow-up, you're going to have, once again, a mixed review of questions to help prepare for your test. You have some limit problems. We haven't thought about those in a little while. Working on this group of questions should be great examples for you to explore. Notice, 11 through 15 are optional optimization practice problems. If you feel confident with your optimization problems, please don't worry about them. If you feel you need a little bit more practice, these are some good problems to explore. You have a fabulous day.